My name is Michael and I make weekly videos on sports science. If you like this kind of content, you can show your support by subscribing to the channel, liking this video, or leaving a comment. In today's video, we're looking at how we can use the Broom package to create individual linear models for our athletes. This is especially useful when we're working with a large set of data or we have a large pool of athletes to work with. When creating a model to describe the relationship between two or more variables, we can use a linear regression model to show the predictive impact that one variable has on the others. In this example, we're looking at the relationship between distance and RPE in the team setting. Now we can create one model for the entire team, but this is going to have some limitations. It's going to lack some context, and it's not going to be specific to the demands that each individual experienced. So then the question becomes, how can we create an individualized model for each athlete? When we run the model for the entire team, we see that we have a multiple R-squared of 0.7653 and a p-value of less than 2.2 to the -16th. And while this shows great information about how the team generally responds to the distance that they covered, it doesn't provide specific information about each athlete's relationship between RPE and distance. Now normally in R we can use the group by function to group by the athlete's name and then run a model for each of the names. For whatever reason, it doesn't work when we're looking at the linear model. So if we group by name and then run a linear model of distance and RPE, when we run that summary there, we see that we return the same model that we just ran for the entire team. Now if we were to do something like a correlation coefficient using the group by name, when we run that, it's going to return the individualized correlation coefficient. And while this provides great information about the relationship between distance and RPE for each athlete, it doesn't provide statistical significance of our correlation coefficients. So from here we have two main options. The first option is that we can manually create a model for each athlete, which is going to be time consuming and there's a lot of room for error. Or we can use the nest function to create a list column for each athlete where the data is implicitly summarized. From there we can use the Broom package to create a linear model for each athlete. So to create our individual linear models, we're going to use the nest function. So the first thing that we're going to do is create a new data frame calling it nested_data, where we're grouping by the athlete's name, and then we're going to nest that data. So when we run those lines of code there and then view our new data frame, we see that our athletes are stored in one column, and then we have a list column of our data in the second column. So if we clicked on this first one here, we would then only see Bill's data, and this is where we're going to call our linear model from to create that relationship between RPE and distance. Once we've done that, we're going to create a function of our data frame where we're going to store the linear model. So here we're calling it nest_lm, where it's a function of our data frame, where it is a linear model looking at the relationship between distance and RPE, and the data is of that df data frame. So when we run this line of code, it's going to return in our console below. So the next step is to use the map function to create the linear model for each athlete. So we're using the same data frame name nested_data, and we're mutating, so we're adding a new column, calling that column model, where we're mapping over our list columns under that data column, and we're running that linear model of distance on RPE for each one of our athletes. So now once we've ran those lines of code, we can see underneath our nested_data, we have that new column called model, and stored within it is our linear model. So if we click here, it is a lot of data, kind of complicated to understand and digest. So the next step is to kind of clean things up a little bit, make our data a little bit tidier so we can pull the information that we need. And this is where the Broom package comes in handy. We're using the same data frame name, nested_data, and we're mutating, so we're creating another column, calling it model_tidy, where we're mapping over that model column and we're tidying up that data. So when we run those lines of code there and view our nested column, we have our model tidy. Moving past that, we can also use the glance function within the Broom package. We're running that same kind of block of code here, calling our new column model underscore glance, and we're mapping over model, and we're using the glance function. When we do that, it's going to return our model underscore glance, and when we click on this variable right here for Bill, it's going to give us some of the statistics that we would commonly see in a summary of our linear model. And since this provides the statistics that we're looking for, we're going to unnest the data frame and then pull the data from here that we want. That way we can compare the relationship between distance and RPE for each athlete. So to unnest our data, all we have to do is create a new data frame. We're calling this one unnested underscore data, where we're unnesting by model underscore glance. When we run this line of code and then view our unnested data, we'll see that we have our column of our name for each individual athlete. We still have our list column for our data, as well as our model underscore tidy. And then we've unnested by our model underscore glance. So now we see the statistics that we want. And the last step is to select the metrics that we want. So we're using our unnested underscore data frame. We're selecting the name. We're selecting the R squared, the adjusted R squared, the statistic, as well as the p-value. When we run this line of code here, it's going to return our 10 athletes, the R squared for each athlete, the adjusted R squared for each athlete, their statistic, and the p-value. So if we recall at the beginning for the team, the overall relationship between distance and RPE, the R squared was 0.7653 with a p-value of less than 2.2 to the negative 16th. Here we can see the individual R squared for each athlete, and we can even sort lowest to highest. So we see that some have a 0.628 R squared, while others have a 0.92. So this is going to provide a lot more information to our coaching staff so they can make better decisions that is based with data.